Hello students, in this video we are going to discuss the refraction through a prism. The prism ABC is as shown in the figure. A ray OP is incident on AB refracting surface and at point P it undergoes the refraction, and PQ will be acting as the refractor ray. At AC again the refracting surface is there, so here it undergoes one more time refraction. It will bend away from the normal. Two times the ray is undergoing the refraction. So at the first refraction, angle of incidence is I1 and angle of refraction is R1. Here the refractor ray bend towards normal, and angle of deviation delta 1 is equal to I1 minus R1. When it undergoes second time refraction, R2 acts as angle of incidence, I2 acts as angle of emergence or angle of refraction, and the angle of deviation delta 2 can be written as here I2 minus R2. So QR is emergent ray, and this MR, that means by extending this QR in opposite direction, it intersect at point M with incident ray. Angle of deviation is delta. Now, what is the total angle of deviation? The total angle of deviation delta is equal to delta 1 plus delta 2, that is I1 minus R1 plus I2 minus R2, that is equal to I1 plus I2 minus of R1 plus R2. You can take it is equation number 1. In triangle PNQ, we have R1 plus R2 plus theta is equal to 180 degrees. We can take it is equation number 2. Again in the quadrilateral APN, APNQ, A plus 90 degrees plus theta plus 90 degrees is equal to 360 degrees. From this, A plus theta is equal to 180 degrees. We can name it equation number 3. From equation number 2 and 3, we can write R1 plus R2 is equal to A. Name it equation number 4. From equation number 1 and 4, we can write delta is equal to I1 plus I2 minus A. Name it equation number 5. If you apply the Snell's law at the first refracting surface, we can write mu1 sin I1 is equal to mu2 sin R1. It is from Snell's law. At the first refracting surface AB. Here mu1 is the refractive index of the surrounding medium. Mu2 is the refractive index of the prism. Okay. Now come to the condition minimum deviation. For minimum deviation, we have the conditions are at minimum angle of deviation. We will have I1 is equal to I2. We can name it I. R1 is equal to R2, that is equal to R. And the refractor ray PQ will be parallel with BC base. And from equation number 4, we have R1 plus R2 is equal to A. From that, R is equal to A by 2. And from equation number 5, the delta value becomes delta minimum. So delta minimum is equal to 2I minus A. We will get from this I is equal to A plus delta minimum divided by 2. The corresponding graph will be like this. If you are taking angle of deviation along y-axis, angle of incidence along x-axis, the graph comes like this. At certain value of angle of incidence, the angle of deviation will be minimum. That value is minimum angle of deviation. Now we can name the previous Snell's law equation number 6. Now from equation number 6, we can write mu1 sine of I1 is but I sine of A plus delta minimum divided by 2 is equal to mu2 sine of R1 is there. We can write sine of A by 2. From this we can write refractive index of the prism with respect to refractive index of the medium is equal to, we will have sine of A plus delta minimum divided by 2 whole divided by sine of A by 2. Be careful here. So this is the refractive index of the prism with respect to the surrounding medium. Most of the students will do the mistakes here. Be careful. If the surrounding medium of refractive index mu1 is equal to 1, that means if you are placing the prism in air, and refractive index of the prism mu2 is equal to mu, if you consider, then the above expression becomes mu is equal to sine of A plus delta minimum divided by 2 by sine A by 2. This is the refractive index of the prism whenever it is placed in air. But whenever it is placed in any medium, we can write the previous expression. Thank you. The concept is most important. The problems will be asked based on the prism, including the concept of total internal reflection. Thank you.